So let's try another partial fraction example here. We want to integrate 2x squared plus 3 over x cubed minus 2x squared plus x. Well, notice that the power on the top is less than the power on the bottom, so we don't need to long divide. We want to factor our denominator. We can factor an x out of there. We'll have left x squared minus 2x and then plus 1. And then this will FOIL backwards. X and x, factors of 1 that add up to -2, -1. So that's x minus 1 squared. So our 2x squared plus 3 over x minus 1 squared, we want to write the general form of the partial fraction decomposition. So we'll have one term from the x in the denominator, and then we'll have two terms from the x minus 1 squared. One term will have an x minus 1, and the second term will have an x minus 1 squared. And then in the numerator, since these are all linear, the inside here is linear, these will just be constants. We'll call them A, B, and C. So what we want to do first here is multiply through by the LCD, which is x minus 1 squared. So here, this cancels the denominator. We're left with 2x squared plus 3. And now we take this whole expression multiplied in times each term. So when we multiply by the first term, the x's cancel. So we're left with a times x minus 1 squared. When we multiply times the middle term, one of the x minus 1's will cancel. So we're left with b x minus 1. And when we multiply n times the last term, both x minus 1's cancel. And we're just left with c times x. And so now we want to pick values for x to get three equations here. So we could use x equals 0. On the left, 2 times 0 squared plus 3, which is 3. On the right, 0 minus 1 is -1 squared is 1, so that's just 1a, or a. Here, b times 0 is 0, c times 0, 0. So everything else drops out. So a equals 3. X equal 1 is another 0 for the denominator, so I'll try that. X equal 1, plug that in. On the left, 2 times 1 squared plus 3, 5. On the right, 1 minus 1, 0. That cancels out. And then here also 1 minus 1, 0. So those first two terms drop out. We get c times 1, c. So we know a and c. And then there are no more zeros in the denominator. We used them all. So now you can pick any other number, like x equal 2, for example. So on the left, 2 squared is 4, times 2, 8, 9, 10, 11. On the right, 2 minus 1 is 1, squared is 1, so 1a. B times 2 minus 1, so 2b. And then c times 2, 2c. But we know what a and c are. They're 3 and 5. So plug in a 3 there for a, plus 2b, and then 2 times c. C is 5. 2 times 5, 10. So we've got 11 is 13 plus 2b. So bring the 13 over as a negative. 11 minus 13, -2, equals 2b. Divide both sides by 2, so your b is going to be -1. So that means this integral, we can break this up as our a is 3, so 3 over x. Our b here is negative 1, so minus 1 over x minus 1. And then our c is 5, plus 5 over x minus 1 squared dx. So these first two we know how to integrate, right? Pull the 3 out in front. Antiderivative 1 over x is ln x, absolute value. This looks like g prime over g, right? Derivative of x minus 1 is 1. So minus ln, absolute value of the denominator, x minus 1. And then antiderivative 5 over x minus 1 squared. So the 5 we can pull out in front. We got 1 over x minus 1 squared. So this, we could actually use a u substitution, u equal x minus 1. So du is going to be dx. So this is 5 integral 1 over u squared du. So 5 times the integral of u to the minus 2 du, which will be 5 and then u to the minus 1 over minus 1. So that's negative 5 over u, which is negative 5 over, or u is x minus 1. So minus 5 over x minus 1, and then plus c. And we got it. So that's a complete partial fractions. And this is using undetermined coefficients when you plug in values of x.